Okay, I'm going to take a few minutes here. We're going to do three practice problems. The first two having to do with economic impact, or the first one I should say. The second one, present value, and then the third one, a salary regression like we saw at the end of Chapter 2, or the appendix to Chapter 2, when we had a little bit of a regression review. So let's start with the first one. Hopefully you can see it okay here. I know the font's a little bit small, but I wanted to still fit on your screen the problem, and I'm going to solve it using Excel. So you're tasked with calculating the economic impact of the Bengals Stadium in Hamilton County. We're going to assume the stadium adds $45 million in new consumption. So new is a key word there, new consumption. If the marginal propensity to consume in Hamilton County is 0.7, which would mean that the propensity to save is 0.3, right? Because remember, the propensity to consume plus the propensity to save equals 1. You either consume or save your money. So here, the MPC, or marginal propensity to consume, is 0.7. We're going to assume there's a leakage of half of the new income. Remember what that leakage means. It means the income comes in, but immediately that income, a big part of it, in the case of sports teams, goes out in player salaries. A lot of those players live outside of our area of impact, which is Hamilton County here. And so that money leaks out. And the question is asking, what is the impact on the county economy given the multiplier, which you can calculate using method A. And this question is asking you to put your response in millions of dollars. Okay, so first let's see where in our notes we can find the answer to this, or the equations that we need. So look right here, Chapter 6. Hopefully this slide looks familiar to you. We see method A for calculating a multiplier here. And we also see here marginal propensity to consume. These economists estimating it at about 6.7 or 0.67 on average, or 2/3. In our problem, it's giving us a marginal propensity to consume of 0.7, so pretty close to that. They also say leakage is usually about a half here, and that's what was given in our problem as well. So first we need to calculate, use this equation here to calculate this multiplier. Alright, so let's go back to our Excel spreadsheet. I would set this up something like this. Marginal propensity to consume, leakage, and what else do we have in here as well? Oh, new money. So that's the new money coming in. So in this problem, we have a marginal propensity to consume of 0.7. We have leakage of 0.5. And our new money was 45 million, and the answer was to be given in millions of dollars, so I'm just going to leave it at 45. If you really want to get technical, you can put in millions of dollars, like that. Okay, so now we've got our variables in here. Now I'm going to put the equation in here. So first, I'm going to calculate the multiplier. There we go. And the way that I'm going to do that is 1, here's our equation, divided by 1 minus, we had the marginal propensity to consume, which was this, times our leakage, which was this, right? There we go. Let me make sure I've got the right. I need one more parentheses, I think, for that equation. There we go. So we get a multiplier of about just over 1.5. That looks pretty similar to the example that was calculated here on the slide. And the reason that it looks so similar is these numbers are pretty similar that were given to us in the problem, right? Instead of 0.67, we had 0.7 given in our problem, and so it pushed that multiplier up just a bit, but pretty close, right? Now we want to calculate the economic impact, which is what the question was asking for. That is simply going to be the new money times our multiplier, and we get $69 million, just over $69 million. So that's the answer here. If I was going to input this on the test, I would put 69. It says should be in the millions of dollars, so we could just put 69, or we could put 69.23 as the answer there. All right. Let's look at the second problem. So you work for Hamilton County. You're renegotiating the lease for the Bengals Stadium, which a lot of county commissioners have tried to do but been unsuccessful. The team offers to pay the county $150,000 in rent each year for the next 3 years, the first payment being 1 year from now. The current annual interest rate is 3%. What's the net present value of these, or what is the present value of these payments rounded to the nearest $100? So let's put our variables in here again. Payment, it's $150,000, right? Yes, it is. There we go. What else do we have here? Interest is 0.03, and years is 3. Let's do our equation here. So present value, and this is going to be, let's look at this so you recall. So this is Chapter 7's lecture. Here you see the value of a stream of benefits, right? Now, we should already be able to tell, just intuitively, we should know that $1 today is worth more than $1 tomorrow. Remember this question right here. We said, yes, we'd much rather have $1 today as long as there's a positive interest rate, because we can invest that dollar and make more by tomorrow. Whatever the interest rate is, of course, it'd be very small, a couple pennies maybe, or a penny, but it's still more than getting that dollar tomorrow. So by that logic, we should know, okay, this is 3 payments of $150,000, which would come to $450,000 total, right? But we're not getting that money until 3 years from now, or the end of 3 full years. So I know that this answer has got to be less than $450,000, because that $450,000 3 years from now is worth less presently. So let's do this calculation here. Again, we're using this equation here, so we have the benefit in year 1 divided by 1 plus the interest rate plus the benefit in year 2 divided by 1 plus the interest rate squared, right? So let's make this happen in Excel. Alright, so equals this. So let's do the first one. The first payment is that benefit divided by 1 plus interest rate. There we go. Let's see, we need one more. There we go. Then plus, now we're going to do the second year. The benefit again. There we go. Divided by, and here we need, let's see here, we're going to need a couple parentheses here, I think. 1 plus our interest rate there, then we need this to the second power. There we go. There we go. Then we need plus, this is a 3-year deal. Again, the benefit itself divided by 1 plus our interest rate, and that is going to be to the 3rd power in year 3. Whoops. To the 3rd power. And then the last parenthesis. There we go. So what happens here? We get an answer of $424,000, 291.70 cents. It comes out, looks like that could be right. It's less than 450,000 by a little bit, so that seems to be correct to me. 424,291 rounded to the nearest hundred, so that would be 424,300. 424,300. There we go. And our next equation here, we've got a salary situation. So you're the general manager of the Red Wings. Each player is a free agent, and you can sign any of the players listed below for $2.5 million, given the following regression equation that models player salaries in the NHL, where all the variables are statistically significant. Which of the following players would you prefer to sign to your team according to this model? Okay, so let's see here. Let's put this in. So we have a constant of 5,566,400. We have goals are worth $71,928 each. Assists are worth $20,403, and all-star appearances are worth almost $100,000, $98,430. There we go. So let's look at our people here. First, we'll start with Derek, and let's see what he is worth. Derek's value we can put here. Whoops. Don't want to do that yet. This is going to be the value column. These are the players available. Derek's value is going to be the whoops, not that one. We want, excuse me, this one. The constant plus the goals times, how many goals does he have? 20 goals. 20 plus assists. How many assists? 45 plus this. He doesn't have any all-star appearances, so we could actually leave this off. Whoops, what's my problem here? Equals B1 plus B2 plus B14 times 0. Oh, I know. I just wrote these wrong. Sorry about that. Let's revise this equation here quickly. This needs to be, I didn't tell it times in Excel. Just need to add in my times, my parentheses here, just to make sure that it knows, Excel knows the order of operations. There we go. There we go. All right, so Derek looks like a pretty good value. He's worth almost $3 million. Let's try Joe. I am going to drag this down here, but whoops, I can't do that. Hold on. I'll tell you what I'm going to do. I'm going to make sure that these, if I put the dollar signs in here, I can just drag the equation down. If you remember from Excel, this is telling it to always use that cell. There we go. All right. Now, let's drag this down. We're going to have 4 different players. And I'm going to replace the numbers. So, Tyler and Kevin. All right. So for Joe, I've got to replace these numbers. So Joe has 25 goals. So we're going to do 25 goals Joe has 30 assists, so he doesn't have as many assists as Derek. I'm going to replace this with 30. And Joe has 2 All-Star appearances. Nice work, Joe. And he's worth more than Derek. All right, let's look at Tyler. Tyler has just 10 goals. And Tyler has 65 assists, so he has quite a few assists. 65 assists. And he does have 1 All-Star appearance. All right, still a good value for $2.5 million. Let's try Kevin. Kevin has 14 goals. Kevin has 55 assists and 1 All-Star appearance. 1. Also a good value. All right, so all of these players, it appears, for note in the question, it says that we can sign them for $2.5 million. They're all worth more than $2.5 million according to the equation, but looks like the best value for our money here is Joe. All right, buddy. Nice work. Actually, if I'm Joe's agent, I'm thinking, hey, you need to ask for more than $2.5 million. But our equation says they're available to sign for $2.5 million, so as the GM, Joe is my choice based solely on this regression equation. That would take into account the way that this regression equation would have been built was all player salaries, put their stats in, find right where the regression line is, which gives us these coefficients, and all of these players appear to be a good value at $2.5 million. Joe is the best value for our $2.5 million. All right, so hopefully going through this helps you a little bit in terms of some practice problems, problems that you might see on some of the assessments here. Obviously, you can always rewind this video and watch it again if you need to, or ask me questions if you don't understand anything that I did here.